Hello, in this video we're going to be talking about trigonometric functions of any angle. And our essential question, how can you use the unit circle to define the trigonometric functions of any angle? You're going to learn how to find trig functions of any angle and also how to use reference angles to evaluate trigonometric functions. Okay, we say any angle because in previous math classes you have learned how to find the trigonometric functions of angles that are greater than 0 degrees and less than 90 degrees on a right triangle. This time we're going to use a circle to find the trig functions of any angle. Okay, so first our general definitions of trig functions. Okay, if I were you, I would take a moment to copy this information down. You can hit pause and have time to do that. But basically what it says is that if you have an angle in standard position, you can use the Pythagorean theorem and take that angle to the nearest x-axis to draw a right triangle. And then that would be how you use a circle to find trig functions. So for example, if I have an angle with its initial side on the positive x-axis, that's going to put it in standard position. Okay, and maybe I want to draw the terminating side on this in that location right there. Okay, I'm actually going to draw right here to the nearest x-axis down here, and then this triangle right here that you see in blue, if I apply the Pythagorean theorem to that and say that this is A, this is B, and this is C, a squared plus b squared equals c squared, that gives me the ability to find the trig functions. Okay, so if we make the radius of our circle exactly equal to 1, as opposed to any length whatsoever, now we are taking our information more specific down to what's called a unit circle. So a unit circle has a radius length of exactly 1, okay? And in that case, sine of theta is going to be y over r, but in this case, r is 1, so y divided by 1 is just y. Cosine of theta is x over r, and again, r is equal to 1, so this is just x over 1, which is x, okay? And a good way to remember this, we have this point, x, y. All of the points around your unit circle, anywhere on the circle, are going to be in the form of cosine of that angle that terminates at that point, and then sine of that angle that terminates at that point, okay? And if you want a little cheat way to remember which goes with which, you can think of x, y as being in alphabetical order, and also cosine sine is in alphabetical order. So the x tells you the cosine of your angle, and the y tells you the sine of your angle. Okay, let's apply that to this first example. We have evaluating trigonometric functions using this point, -4, 3. That is on the terminal side of this angle, theta, in standard position. We want to evaluate the 6 trigonometric functions of theta. Okay, so if we look at our triangle right here, here we have the value of r, and then I'm going to draw this triangle to the nearest x-axis, and this is going to give me a triangle that I can use the Pythagorean theorem on. Okay, so if this point is -4, 3, that means that on the x-axis I've gone -4 units, and then on the y-axis I've gone 3 units. So then I just take 3 squared plus -4 squared equals r squared. Okay, when you square, add, and square root, you find out that r equals 5. So the hypotenuse has a length of 5. Now we have all 3 of our values, so we can find the 6 trig ratios, the 6 trig functions, right? Sine as opposite over hypotenuse, or as y over r, is just going to be 3 over 5. Cosine of theta, being x over r, is going to be negative 4 over 5. And tangent of theta, being y over x, that's going to be 3 over negative 4. Okay, and then to finish your 6 trig functions, you've got the cosecant of theta, which is the reciprocal of sine, right? So that's going to be the reciprocal of 3 over 5, which is 5 over 3. Then you've got the secant of theta. Secant is the reciprocal of cosine, so that's going to be the reciprocal of negative 4 over 5, which is 5 over negative 4. And then cotangent is the reciprocal of tangent, which is going to be the reciprocal of 3 over negative 4. Negative 4 over 3. And those are your 6 trig functions for an angle that is in standard position and passes through the point negative 4, 3. Okay, this time let's use the unit circle. So unit circle means that the radius is equal to 1 to evaluate the 6 trigonometric functions for this angle, theta equals 270 degrees. Okay, so if I sketch that angle, 270 is like going around 90 degrees, another 90 degrees for 180 degrees, and then another 90 degrees, putting us at 270 degrees. So it's going to be this angle that terminates right here on the negative y-axis. Okay, so if we think about a unit circle with a radius of 1, r equals 1, that means that this point right here on the negative y-axis is going to have a value, coordinates of 0, negative 1. Okay, so remember, this first one tells me the cosine of the angle, and the second one tells me the sine of the angle. Okay, so right away I know that sine of 270 degrees is going to be this y value of negative 1. Cosine of 270 degrees is going to be the x value of 0. Tangent of 270 degrees is going to be y over x, which is negative 1 over 0. And then cosecant of 270 degrees is going to be the reciprocal of sine. If I have negative 1 over 1 and I do the reciprocal of that fraction, it's going to be negative 1 over 1. And then secant of 270 degrees is going to be the reciprocal of cosine. So instead of 0 over 1, it's going to be 1 over 0. And then tangent of 270 degrees, the reciprocal of that is cotangent of 270 degrees, which is the reciprocal of negative 1 over 0, which is 0 over negative 1. Okay, now make sure you understand you cannot divide by 0. So the tangent of 270 degrees is actually undefined. And likewise, the secant of 270 degrees is actually undefined because you cannot divide by 0. Okay, so these are the 6 trig functions of theta equals 270 degrees. Okay, our next problem, we're going to talk about these reference angles. Now, you actually already know what a reference angle is because I've mentioned it several times. A reference angle is basically that angle that's made when you take the terminating side, so this being the terminating side, and you draw the right triangle to the nearest x-axis. It's this angle right here, right? Which is the same as that angle right there. So if your angle terminates in quadrant 3 and you've got your terminating side right here, you go to the nearest x-axis right? And this is going to be your reference angle. If your angle terminates in quadrant 4, you take a point on your terminating side and you go to the nearest x-axis, and this is going to be your reference angle theta prime. Okay, so let's find reference angles. Let's find the reference angle if theta is 5 pi over 3. Now 5 pi over 3, that's in radians. I know that because there is no degree symbol. Okay, if I draw that, I know that going around my unit circle, or going around my axes, I've got pi over 2. This is pi. This is going to be 3 pi over 2. And this is going to be 2 pi. Okay, 5 pi over 3 is just a little bit shy of 2 pi because it would really be 5 pi over 3. We could say that it is 6 pi over 3 for 2 pi. Take away something gives us 5 pi over 3. So what is that something? Let's go ahead and draw that. So my angle starts here on the positive x-axis and goes around and terminates here. And we are looking for this reference angle, right? How big is that reference angle right here? Well, 6 pi over 3, take away pi over 3 leaves us with 5 pi over 3. So our reference angle is going to be pi over 3. Okay, that's going to be the reference angle if you go to the nearest x-axis. Okay, for B, we have theta equals negative 130. We're looking for the reference angle if our original angle is negative 130. So again, I'm going to sketch this. I'm going in the negative direction. So this is 0. This is negative 90 degrees. This is negative 180 degrees. 270 degrees if I'm going around, starting from the positive x-axis and going down, that's going to be negative. Now, negative 130 degrees is going to it's going to be between negative 90 and negative 180. Okay, the question is, how far between? So what is, if I go and stop right there, right? What is this reference angle? How far do I have left to get to negative 180 degrees? Okay, well that's pretty simple. It's just, what is the difference between negative 180 and negative 130? So the difference is going to be 50 degrees, right? So my reference angle would be 50 degrees. All right, reference angles come in handy because if you're using a reference angle and then you just know, oh, if my angle is in quadrant 1, it's my sine, cosine, tangent, cosecant, secant, and cotangent, all of them are going to be positive, okay? If my angle is in quadrant 2, instead I can think about my reference angle, and in this case, sine is going to be positive, and all of the others are negative. Cosine is negative, tangent is negative, okay? And the reciprocal functions follow their primary functions. If my angle is in quadrant 3, tangent is going to be positive. And if my angle is in quadrant 4, cosine is going to be positive. So all of them are positive in quadrant 1. Sine is positive in quadrant 2. The others are negative. Tangent is positive in quadrant 3, the others are negative, and cosine is positive in quadrant 4, the others are negative. And if you put all of that together, we get this nice mnemonic, A, S, T, C. And the mnemonic, much like PEMDAS, right? Please excuse my dear Aunt Sally, is really parentheses, exponents, multiply, divide, add, subtract. All sine, tangent, cosine, your mnemonic is going to be all students take calculus. Okay, that is merely to help you remember what trig functions are positive in which quadrants. Quadrant 1, all of them are positive. Sine, cosine, tangent are all positive. In quadrant 2, only the sine is positive. In quadrant 3, only the tangent is positive. And in quadrant 4, only the cosine is positive. Okay, so let's take that back and actually apply this with notes that we took the other day in our previous lesson about the sine, cosine, tangent, cosecant, secant, and cotangent values for your three special angles. And these were these special angles that you learned about in geometry, right? So 30 degrees, 45 degrees, and 60 degrees. And then we also, in the lesson before this one, we talked about converting from degree measure to radian measure. Okay, so we're going to bring a bunch of stuff together in this one example. So first, if we want to evaluate the tangent of negative 240 degrees, I'm going to draw my reference angle. So negative 240 goes in the negative direction, right? This would be negative 90 degrees, this would be negative 180 degrees, and this would be negative 270 degrees. Okay, so negative 240 is close to negative 270, negative 240 degrees. Okay, but I'm going to take and I'm going to draw my reference triangle so that I know that my reference angle, this angle right here, how far is it from 180 to 240? Well, it happens to be 60 degrees. Okay, so I'm going to go to 60 degrees in my table. Okay, I'm looking at tangent of 60 degrees. That's going to be square root of 3. Okay, but that's just my reference angle. Okay, in reality, what I'm looking at is an angle that terminates in quadrant 2, in which case the tangent of that angle, negative 240, has to be negative. So negative square root 3. Okay, for this example, we want the cosecant of 17 pi over 6. Now 17 pi over 6 is quite a bit, right? If I go to my my radians around my circle, right? From here, I've got 1 pi, 2 pi, go again, that's 3 pi, but really 3 pi is the same as if I multiply by 6 over 6, that's going to be 18 pi over 6. I need to back off that just a little bit, so it's really going to be this angle right here, right? So I'm going all the way around once and then stopping at this angle. Okay, so now the question is, what is my reference angle that I need to be using? So this reference angle right here is a pi over 6 radian angle. Okay, if you remember, pi over 6 radians is the same as 30 degrees. So now I can go to my table, 30 degrees. I'm looking for cosecant. Okay, cosecant is right here. So that's 2. And now I pull in my all students take calculus. Okay, all of them are positive here. Sine is positive in this quadrant 2. Okay, and since cosecant is the reciprocal of sine, cosecant is also positive. So the answer for this one, for cosecant of 17 pi over 6, the answer is just 2. Okay, and then lastly, we've got this problem right here. We are solving a real life problem about the distance, the horizontal distance traveled, right? Projectile motion, the horizontal distance traveled by a golf ball when you hit it with the right club. Okay, if you are familiar with golfing, you've got like a putter, you've got a driver, you've got all different kinds of golf clubs that you can choose from, and each one, the head of that golf club, the face of it that hits the golf ball is angled just a little bit differently. And that is very, very intentional, okay? So in this problem, you're going to want to copy down this formula because you're going to use it in your big ideas math assignments. D equals V as in Victor, V squared over 32, and that's multiplied by sine of 2 theta, where D is the horizontal distance that it's traveling. D is the distance. Okay, V is your initial velocity, and theta is the angle at which it's hit, the angle that it makes with the ground when it's first hit, okay? Our problem actually gives us quite a bit of this information. We want to estimate the horizontal distance, so that means that we're trying to find D, traveled by a golf ball that is hit at an angle of 50 degrees, so that means theta is 50 degrees, with an initial speed of 105 feet per second, so that means that V is 105. So now all we need to do is plug into our formula. D equals the velocity squared, so 105 squared, divide that by 32, and then multiply by the sine of 2 times your angle, and your angle is 50 degrees, okay? You can go ahead, because this entire part right here is all numbers, you can go ahead and plug this into your calculator. There's no variables in this part right here. And when you plug that into your calculator, you get that D equals 339.297, okay? So if the problem says approximately or estimate, this is a fairly large number. I would round it to the nearest whole number and say that it is about 339 feet, okay? If the problem says to the nearest tenth, well, that's easy. That's your 10th place, right? And the 2 would round up based on the ninth. So that would be D equals 339.3 feet. Thank you for watching.